I believe I can get better results and build robots more quickly using the Raspberry Pi and Pico together, horizontally scaling in even a small robot using ROS2 and MicroROS. Welcome to our Tech Focus channel, where we explore the synergy between the Raspberry Pi Pico and robotics. I'm John, your concierge to this fascinating world of IoT and innovative technology. This is a 3-minute summary of the full episode on maximum raspberry robot architecture. I had the honour of presenting my work and insights to the ROS2 embedded working group, and I'm excited to share the highlights with you. If you have time, why not check out the full version of this video? So what do I mean by the maximum raspberry robot architecture? Well, when I first got into the world of robotics, I was trying to build everything on a single platform, on a single Raspberry Pi. And that isn't terribly scalable. You can't really go and buy a bigger Raspberry Pi. My approach to getting around that is to put in a distributed system on the robot. Distributed systems are something I'm pretty comfortable with. It's what I did my PhD on some 25 years ago or so. We can't just have all of these nodes talking to each other using custom protocols. That would just be unsustainable. So of course we place it on some sort of bus architecture. If you know anything about ROS, MicroROS, and have followed anything on my channel, you'll know that what I'm really talking about then is each one of those Raspberries is really a Raspberry Pi Pico and perhaps a Raspberry Pi 4. And they're communicating using MicroROS to connect the Picos into the world of ROS, and ROS is managing that backbone of communication. In this 3-minute summary version, I'm going to quickly jump through the intro to me, a bit about what my Pico robots are, about the robot architecture itself, and some of the challenges I've had. Really, my background is not in robotics engineering. I'm actually an enterprise architecture and IT leader. I got into robots more as a hobby, but that has now become sort of my world as I now really train people in writing code for these sorts of embedded systems on the Raspberry Pi Pico, and of course making some really interesting, exciting content for YouTube. I started my journey into robots building a hexapod some years ago, before Picos and MicroROS existed, and that was really a single Raspberry architecture. It ran all on a Raspberry Pi 4. That had limitations because the power to calculate the angles of those legs is stuff that actually I want to use for image processing. So you're trying to make compromises all the time. What we really want is to be able to distribute it. My next journey into robots was more recent when I started that distributed journey, and you probably saw it on the channel. I built a video turntable. I used a Raspberry Pi Pico to do all that low-level calculations and management of a stepper motor and the zeroing position using a Hall sensor, while using then a Raspberry Pi 4 to do the high-level management and control process. A more complicated robot would be DDD, my DIY dev droid, a 3-wheeled robot designed to explore the world of robotics and ROS2 and MicroROS. I used the Raspberry Pi Pico once again to do the low-level management, so it's controlling the speeds of those wheels and allowing it to move around, whereas the high-level functions are actually on the Raspberry Pi. I use the same architecture for Robot Center. So the architecture here really at the high level is high-level functions go on the Raspberry Pi, whereas the low-level stuff, all that hardware and interfacing to it, goes on the Pico. That makes sense as an architecture. So let's have a chat about that architecture. What's down there in that Pico? Well, we're using MicroROS really as the communication layer, and we're using the FreeRTOS kernel to provide control, semantics, task management, etc. So my architecture here is I use the FreeRTOS scheduler on the Pico, which I can run on one core or both cores, so making use of every ounce of power of my Pico. And then I use tasks to actually manage the various functions. So we have a MicroROS bridge, which is responsible for solely communicating out to the world of ROS2, and all messaging goes through that task, whereas things like the motor control and sensors all become separate tasks within that scheduler space. Where am I up to on MicroROS bridge? Well, my bridge architecture is able to publish, subscribe and do message handling. So what were the challenges? Well, resilient comms, definitely, custom messages and that C++ binding. So, using this architecture, I've built everything from really simple robots that just have a single turntable and a single joint, right up to, droids that can run around my house, or robot arms. They all use this same architecture of MicroROS and ROS2 working together on the Raspberry Pi Pico and Raspberry Pi 4. What's holding me back from building robots and droids? Well, like lots of us, I guess it's time and money. They're coming though, so do keep watching and supporting my channel. I do appreciate it. Did you enjoy the ride today? Well, why not fuel my caffeine addiction and hit that super thanks button down the bottom. Your support keeps these gears turning. And please smash the like button and hit the subscribe and join the tech tribe. Your enthusiasm is inspiring to me and it helps me keep going. And let's keep moving forward together, pushing the boundaries. Bye-bye for now.